In a move that sent shockwaves through the automotive world, Toyota recently announced the development of a groundbreaking water-powered engine. This claim has the potential to reshape the future of clean transportation. The core of Toyota's bold promise is the idea of a sustainable, clean vehicle that could rival and, in some cases, replace electric vehicles, EVs. While industry giants like Tesla and Elon Musk have placed their bets on lithium-ion batteries to power the future of transportation, Toyota is taking an entirely different approach. Rather than focusing on the energy-intensive, resource-heavy process of battery manufacturing, Toyota is betting on hydrogen, specifically hydrogen produced from water. This decision sets the company apart in an industry dominated by battery-powered cars, offering an alternative that might just revolutionize how we think about fueling vehicles. Toyota's bet on hydrogen power has caused a stir because it introduces an entirely new model of clean energy for transportation. While electric vehicles are often hailed for their eco-friendliness, they come with challenges: long charging times, the environmental toll of battery production, and the resource-heavy nature of lithium extraction. Toyota's water-powered engine aims to sidestep these issues entirely, offering a new path forward. The company's commitment to sustainability is at the heart of this move. By creating a system that uses water, an abundant and renewable resource, to generate hydrogen, Toyota hopes to usher in a new era of transportation that is as clean as it is efficient. As the world moves toward cleaner alternatives to fossil fuels, Toyota's innovation could be the disruptive force that accelerates the shift towards sustainable mobility. The announcement of this water-powered engine marks a pivotal moment in the race for clean transportation, with the potential to challenge the very concept of what the future of cars should look like. While EVs have had a significant head start, Toyota's foray into hydrogen-powered vehicles challenges the idea that battery electric is the only viable path forward. This shift could set the stage for a new kind of competition, one where the future of mobility is determined by a battle between hydrogen and electric power. What is a water engine, really? At the heart of Toyota's bold claim is a technology that uses water to generate hydrogen fuel for vehicles through a process called electrolysis. The engine works by splitting water molecules into hydrogen and oxygen, with the hydrogen then being used as fuel to power the vehicle. This process not only creates a clean and sustainable energy source, but it also produces no harmful emissions. Only water vapor is emitted as a byproduct. Unlike traditional combustion engines, which rely on fossil fuels, or electric vehicles that depend on power generated through a complex and often unsustainable grid, Toyota's water engine offers a potential solution that is both environmentally friendly and efficient. The electrolysis process used in Toyota's water-powered engine takes advantage of renewable energy sources like solar or wind power to generate hydrogen, which can then be used to fuel vehicles. This process eliminates the need for expensive, environmentally damaging batteries while offering a much quicker refueling option. In contrast to electric vehicles, which can take hours to charge, water-powered engines powered by hydrogen can be refueled in just a few minutes, making them far more practical for long-distance travel. The engine's design aims to replace the bulky, complicated systems currently required for hydrogen storage and transportation by generating the hydrogen on demand directly within the vehicle. This eliminates the need for large hydrogen tanks and opens the door for more streamlined and accessible refueling stations. In its simplest form, Toyota's water engine represents a paradigm shift in how vehicles are powered. It takes advantage of the most abundant resource on Earth, water, and turns it into a clean, efficient fuel source. This technology has the potential to make a significant impact on reducing greenhouse gas emissions and reliance on fossil fuels, while also solving some of the key issues that have slowed the widespread adoption of electric vehicles. The implications of this innovation extend beyond just the automotive industry. If Toyota's water engine technology becomes widely adopted, it could transform entire sectors, from public transportation to freight logistics, and set the foundation for a new global energy infrastructure. A vision beyond cars. Toyota's ambition extends far beyond the development of water-powered vehicles. The company's vision for the future of mobility is centered around transforming the entire transportation ecosystem to be more sustainable, diverse, and accessible. While many automakers are focused on electric cars, Toyota aims to offer a broader range of solutions that go beyond personal vehicles. Their water-powered engine technology is seen as just one component of a larger plan to build a sustainable transportation network that includes buses, trucks, and even stationary energy systems that can power homes and businesses. This broader vision involves leveraging hydrogen not only for vehicles but for entire transportation systems, potentially reshaping how goods and people move around the world. In addition to developing hydrogen-powered vehicles, Toyota is working on a variety of hydrogen-based infrastructure projects that could support the widespread adoption of this technology. The company is looking into the development of hydrogen refueling stations, with plans to expand hydrogen infrastructure globally. This infrastructure could serve everything from everyday cars to large commercial trucks, providing a seamless and sustainable transportation network that operates on clean energy. Furthermore, Toyota's commitment to environmental responsibility means that their vision extends into areas outside of just vehicles. The company is investing in hydrogen-powered generators and stationary fuel cells that can provide energy for buildings, industrial equipment, and even power grids. This holistic approach to energy consumption is intended to complement the growing demand for cleaner alternatives in every aspect of daily life. Toyota's efforts reflect a broader commitment to creating a world where clean, renewable energy isn't limited to personal cars, but integrated into all aspects of mobility and infrastructure. In essence, Toyota is not just building a better car, they're building a better future for global transportation. This vision, which integrates hydrogen energy into everything from public transit to industrial infrastructure, positions Toyota as a forward-thinking leader in the clean energy space. While many other companies are focused on revolutionizing personal transportation alone, Toyota sees an opportunity to create a sustainable, interconnected system that can meet the energy and mobility needs of entire societies. The technology that makes it possible. At the core of Toyota's groundbreaking water-powered engine is an advanced electrolyzer, which is a device that splits water molecules into hydrogen and oxygen through electrolysis. This process, when powered by renewable energy sources such as solar or wind power, offers a clean and efficient way to generate hydrogen fuel. Unlike traditional hydrogen production methods, which rely on large-scale facilities and significant energy inputs, Toyota's electrolyzer is designed to operate efficiently and compactly directly within the vehicle. This on-demand hydrogen generation eliminates the need for bulky storage tanks or complicated infrastructure, making it much easier to deploy hydrogen vehicles on a wide scale. The design of the water engine doesn't just stop at the electrolyzer. Toyota's engineers have modified traditional engine components to handle the specific challenges of hydrogen fuel, including its high pressure. Hydrogen gas, while abundant and clean, is difficult to store due to its low energy density and the potential for leaks or explosions in older systems. Toyota's solution is to build a fuel system that can safely store and handle hydrogen without the need for high-pressure tanks, a major breakthrough in hydrogen technology. This new system allows the hydrogen to be produced on demand within the vehicle, significantly improving both the safety and efficiency of the vehicle's fuel management system. Additionally, Toyota has worked to ensure that the hydrogen fuel cells themselves are smaller, more affordable, and more efficient than previous models. The company's experience with hydrogen technology, particularly with their earlier models like the Mirai, has helped refine and improve the fuel cell technology used in these water-powered engines. Toyota is also investing heavily in hydrogen infrastructure, including refueling stations and production hubs, to ensure that the technology can be scaled and made widely available. These advancements in electrolyzer technology, fuel cell design, and hydrogen storage systems are crucial to making the dream of water-powered vehicles a reality. Why it's better than batteries. Toyota's water-powered engine offers several advantages over electric vehicles, by EVs, particularly when it comes to energy storage and refueling times. The most obvious benefit is the fact that hydrogen, when used as a fuel, is is significantly more efficient than the lithium-ion batteries that power electric vehicles. Batteries, while effective, are limited by factors such as charge times, resource-heavy production processes, and concerns about recycling and environmental impact. Toyota's water-powered engine, on the other hand, sidesteps many of these issues by using water to generate hydrogen, a resource that is abundant, non-toxic, and easily accessible. One of the key advantages of Toyota's hydrogen-powered vehicles is the speed of refueling. Unlike electric vehicles, which can take hours to fully charge depending on the charging infrastructure, water-powered cars can be refueled in just a few minutes. This makes hydrogen-powered vehicles far more practical for long-distance travel, eliminating the range anxiety that many EV owners experience when planning trips. The convenience of fast refueling also means that hydrogen-powered vehicles could become more practical for commercial applications, including freight transport, where downtime for charging could result in significant logistical inefficiencies. In addition to faster refueling, Toyota's water engine technology eliminates the need for the massive, environmentally damaging lithium-ion batteries used in electric cars. The production of lithium-ion batteries requires the extraction of rare minerals such as lithium, cobalt, and nickel, which are not only expensive to mine but also contribute to environmental degradation. By contrast, the hydrogen produced in Toyota's water engine comes from water, which is abundant and far less damaging to the environment. Hydrogen fuel cells, unlike batteries, also last longer and degrade much slower over time, meaning fewer replacements and a lower overall environmental impact. Learning from the past. The concept of a water-powered car is not a new one. Over the years, there have been numerous attempts to develop vehicles that run on water or hydrogen, but most of these efforts were either unsuccessful or debunked by the scientific community. The early ideas lacked the necessary scientific foundation or scalability, and the technology required to make such vehicles viable was either underdeveloped or impractical. In many cases, these early water-powered car claims were dismissed as hoaxes or overly optimistic, and the world moved on to alternative solutions like electric vehicles. However, Toyota's approach to water-powered vehicles is different from those earlier attempts. Unlike past efforts, Toyota's technology is backed by years of research, development, and real-world experience with hydrogen fuel cells. The company has been a leader in hydrogen technology for over a decade, with its Mirai fuel cell vehicle being one of the first mass-produced hydrogen-powered cars. Toyota's expertise in fuel cell technology, combined with its resources and commitment to innovation, gives this new water-powered engine the credibility and scalability that earlier water-powered car ideas lacked. Toyota's success is also due in part to the advancements in electrolysis technology, which makes the production of hydrogen from water much more efficient than it was in the past. Today's electrolyzers are smaller, more efficient, and capable of generating hydrogen on demand, eliminating many of the challenges associated with storing and transporting hydrogen. With this breakthrough technology, Toyota is poised to take water-powered vehicles from the realm of speculative science to the roads of tomorrow. By learning from past failures and building on its own successes in hydrogen technology, Toyota has positioned itself as a leader in the next phase of clean, sustainable transportation. The hidden advantage: hydrogen without the hassle. One of the biggest challenges with hydrogen as a fuel source has been its storage and transportation. Hydrogen gas in its natural state is difficult to store because of its low energy density and the risk of leaks or explosions when stored under pressure. Traditional hydrogen storage systems use high-pressure tanks or cryogenic tanks, which require significant energy and infrastructure to maintain. This has been a major obstacle to the widespread adoption of hydrogen-powered vehicles. However, Toyota's water-powered engine technology offers a unique solution to this problem by generating hydrogen on demand. Rather than relying on high-pressure storage tanks, Toyota's system produces hydrogen directly within the vehicle, eliminating the need for bulky and potentially dangerous storage systems. This on-demand generation of hydrogen makes the entire system safer and more efficient, as it eliminates the risks associated with the storing compressed hydrogen gas. The ability to produce hydrogen as needed also reduces the complexity of hydrogen infrastructure, making it easier and cheaper to deploy hydrogen vehicles at scale. Furthermore, Toyota's approach to hydrogen fuel significantly reduces the need for specialized refueling infrastructure. Traditional hydrogen stations require expensive infrastructure for storing and dispensing pressurized hydrogen. But with Toyota's technology, refueling stations can be much simpler and more cost-effective. This simplification of hydrogen storage and delivery makes it easier to expand hydrogen infrastructure worldwide, enabling the widespread adoption of hydrogen-powered vehicles. As a result, Toyota's water engine could pave the way for a future where hydrogen is as accessible and practical as gasoline or electricity, making clean energy a viable alternative for transportation on a global scale. From factory floor to freeways, Toyota's commitment to revolutionizing hydrogen-powered transportation extends far beyond vehicle development. The company is investing heavily in hydrogen infrastructure to support the widespread adoption of its water-powered engine technology. As part of this effort, Toyota plans to establish new production hubs focused on the efficient production of hydrogen fuel cells and related components. These hubs will enable the company to scale its production capabilities and meet the growing demand for hydrogen vehicles. Additionally, Toyota is working on creating an efficient network of hydrogen refueling stations, ensuring that drivers of hydrogen-powered vehicles have easy access to fueling infrastructure. Toyota's investment strategy also includes exploring alternative sources of hydrogen, such as bio-waste, to make the process even more sustainable. By utilizing organic waste to produce hydrogen, Toyota is not only reducing reliance on conventional energy sources, but also contributing to a circular economy. These efforts are part of Toyota's larger vision of a hydrogen-powered society, where clean, renewable energy is used to fuel not just cars, but a wide range of transportation modes, including buses, trucks, and even trains. The company's infrastructure investments are laying the foundation for a future where hydrogen is a primary energy source for mobility. The global race for clean transport. The global race for clean transportation is intensifying, with nations like China and the US leading the way in the electric vehicle (EV) market. However, the challenges associated with battery waste, long charging times, and the environmental impact of lithium-ion batteries persist. Toyota's water-powered engine offers a compelling alternative to EVs, addressing many of these issues by providing a clean, sustainable, and efficient method of powering vehicles. Unlike EVs, which rely heavily on rare minerals and long charging periods, hydrogen-powered vehicles can be refueled quickly and are not dependent on environmentally taxing battery production. Hydrogen also offers the flexibility to be generated using renewable energy sources, such as solar or wind power, creating a truly sustainable energy cycle. This makes hydrogen vehicles even cleaner, as they can be powered by the same renewable sources used to produce the hydrogen. As the global demand for sustainable transport grows, Toyota's water-powered engine could play a pivotal role in diversifying the clean transportation landscape, complementing the existing EV infrastructure with a viable and efficient alternative. The rise of hydrogen technology could ultimately help address the limitations of battery-powered electric vehicles, offering consumers more choices for environmentally friendly transportation. Challenges ahead. While Toyota's water-powered engine technology promises to revolutionize the transportation industry, several challenges remain. One of the primary obstacles is the limited hydrogen infrastructure currently available. Hydrogen refueling stations are sparse, particularly in regions where electric vehicle charging networks have already taken root. Expanding this infrastructure requires significant investment and time, creating a potential barrier to widespread adoption of hydrogen-powered vehicles. Additionally, public trust must be earned, as hydrogen technology has faced skepticism in the past, with many overhyped concepts failing to deliver on their promises. Cost is another challenge. Developing hydrogen infrastructure, including refueling stations and production hubs, is expensive. While Toyota's innovations in hydrogen technology have the potential to reduce costs over time, the initial investments required could limit the speed at which the technology is adopted. The complexity of the technology itself also presents challenges, as the company must ensure the safety and efficiency of its hydrogen production and storage systems. Despite these hurdles, Toyota is working to overcome them by collaborating with governments and industry partners to accelerate the development of hydrogen infrastructure and prove the viability of water-powered vehicles. A broader mission. Toyota's vision for the future goes beyond cars. The company sees hydrogen as a versatile energy source that can be used across a wide range of applications, from buses and trucks to energy systems for building and industries. The company's ambitions are clear. It wants to transform not only the way we drive, but how we use energy on a global scale. In addition to developing hydrogen-powered vehicles, Toyota is working on creating hydrogen-based solutions for stationary applications, such as hydrogen-powered generators and energy systems that can be used to power homes, factories, and entire cities. By diversifying its approach to hydrogen, Toyota is aiming to create a comprehensive ecosystem that addresses multiple aspects of global energy needs. The integration of hydrogen into industrial sectors, energy generation, and public transportation could make a significant impact on reducing greenhouse gas emissions and reliance on fossil fuels. Toyota's broader mission reflects a shift in thinking about energy, transportation, and sustainability, moving away from a focus on individual products and instead creating an interconnected system that supports a cleaner, more sustainable future. This ambitious goal shows that Toyota isn't just about building vehicles. It's about reshaping how the world uses and consumes energy. The fuel cell legacy. Toyota's expertise with hydrogen technology is not a recent development. In fact, the company has been at the forefront of fuel cell vehicle innovation for years. The Toyota Mirai, one of the first commercially available hydrogen-powered cars, showcased the potential of hydrogen fuel cells to revolutionize the automotive industry. Since the Mirai's introduction, Toyota has continued to refine and advance fuel cell technology, driving innovations that make these vehicles more efficient, compact, and affordable. With over 5,000 hydrogen-related patents, Toyota has cemented itself as a leader in the field, constantly pushing the boundaries of what hydrogen can achieve in transportation. The Mirai, which proved that hydrogen-powered vehicles could be both practical and reliable, was just the beginning of Toyota's journey into clean mobility. Building on the lessons learned from the Mirai, Toyota has made significant strides in enhancing fuel cell technology, reducing the cost and complexity associated with hydrogen storage, and improving the efficiency of fuel cell systems. This extensive experience has given Toyota a solid foundation upon which to build its newest innovation, the water-powered engine. Unlike traditional hydrogen production methods that rely on large-scale facilities to compress and store hydrogen, the water-powered engine generates hydrogen on demand directly within the vehicle, eliminating the need for bulky pressurized tanks. This breakthrough could make hydrogen-powered cars more accessible and convenient for consumers, especially in regions where hydrogen infrastructure is still in its infancy. The ability to generate hydrogen on demand within the vehicle could reduce the need for specialized refueling stations, offering an added layer of convenience that electric vehicles with long charging times cannot provide. Toyota's experience in fuel cell technology has equipped the company with the knowledge and resources to tackle the challenges of mass adoption, and its new water-powered engine technology could set the stage for a new era of clean, sustainable transportation. As Toyota continues to build on its legacy of hydrogen innovation, it is poised to lead the charge in the hydrogen revolution. The company's commitment to research and development, coupled with its unmatched expertise in fuel cell technology, positions it uniquely to shape the future of transportation. With years of experience under its belt, Toyota's vision for hydrogen-powered vehicles is not just about improving existing systems, it's about creating a more sustainable, efficient, and practical solution for the entire transportation industry. The future of clean mobility is rapidly evolving, and Toyota's ongoing legacy in hydrogen fuel cell technology ensures that the company remains a key player in the drive toward a cleaner, more sustainable world. Is this the end of EVs? The introduction of Toyota's water-powered engine raises a significant question. Could this be the end of electric vehicles as we know them? While it's unlikely that hydrogen-powered cars will completely replace EVs, Toyota's innovation could signal a shift in the clean mobility landscape. Rather than a competition between hydrogen and electric power, the future may involve a complementary relationship between the two technologies, with both offering unique advantages. Toyota's water-powered engine addresses some of the key challenges facing electric vehicles, including long charging times, battery waste, and resource dependence, offering an alternative that is quicker to refuel, easier to store, and potentially more sustainable. The development of water-powered vehicles could redefine how we think about clean mobility, but it is not necessarily a case of one technology replacing another. Both hydrogen and battery electric vehicles have their place in the future of transportation, depending on the use case and infrastructure. Toyota's water-powered engine could reshape the automotive landscape, offering a new option for consumers and industries looking for clean, efficient, and sustainable alternatives to fossil fuel-powered vehicles. As technology advances, the future of clean mobility may involve a combination of both hydrogen and electric power, with each playing a vital role in reducing global emissions and promoting sustainability.